Greetings, friends, and welcome to my channel on philosophy and artificial intelligence. My name is Casey Hart, and I'm an ontologist and philosopher. And if you don't know what an ontologist is, this is the video for you. By the end of this video, you'll know what ontology is, and who ontologists are, and what we do. To get there, we're going to start by looking at ontology in philosophy, where it all begins, and then we'll see how that translates to ontology outside of the academy. We'll look at it in artificial intelligence in particular, and then make it concrete with a healthcare example. So, in philosophy, ontology is a subdiscipline of metaphysics. So ontology comes from onto for being or existence, and logos for a written or spoken account of. So it's just an account of what exists. In the picture to the right, you can see Roger Federer. He exists. He's got a racket. He's got a ball. There's grass on the field. There's a net, right? Unless you think that, oh, this ontology stuff must be super easy because I can pick out nouns in a picture. In some sense, you're right. But there are more contentious things. Does Roger have a soul? Does that exist? There are holes in the net. Are those holes real things? Or is there just, there's places where there's net, and then there's places where there's no net, and we can call that a hole if we like, but that's not a real existing thing, right? So there are two ways I like to think about ontology or introduce someone to metaphysics and ontology. The first one is the Quinean point. To exist is to be quantified over, which is a little bit technical, but it doesn't have to be that complicated. If I say that everything in this room is mine, right, there are a whole bunch of things. There's this laser pointer, this microphone, my coffee cup. And a way that we can put that into logical notation is we can say for all x, if x is in this room, it's mine. And what are the things that can stand in for x? And it's just the things I was pointing to, right? My phone is in this room, so it's mine. This laser pointer's in the room, so it's mine, etc. All of those things that can stand in for x, those are things that exist on the Quinean picture. That's a way to get our ontology going. Here's another way to think about it. Imagine, and this comes from Ted Cited, who has a book, Writing the Book of the World, and imagine that you were tasked with writing the complete story of everything. So you have to, and if that's a little too big, imagine the complete story of your house or the room that you're in. There's going to be a lot of stuff. It's a long book, right? But if you have to completely describe everything, we're going to need a bunch of nouns. We're going to need a bunch of verbs. We're going to need to describe how those things would behave if someone pushed them, or how would they get destroyed, how long they've existed for, what it is to come into existence. This is the kind of story that you need for metaphysics. And ontology is a subpart of that, right? It's sort of what are all the nouns or things that are created. This is the way I think about ontology and metaphysics in a philosophical context. But outside of academia, it's in some ways much easier and in some ways a little bit more robust. So an ontology is what our business or technology needs to know about and how those things relate to one another. So in some sense, it's going to be much narrower because we can have a domain that describes only the things our business need to know about. But in some sense, it's more complicated because it's not just what exists, but how do those pieces interact with one another? What relationships can they stand on? And in ontology and the philosophical context, it's just about what exists, strictly speaking. So because it's domain specific, your ontology doesn't need to be huge. If you're in healthcare, your ontology needs to describe patients and diseases and hospitals and insurance companies. If you're in oil and gas, you need to describe natural gas and oil derricks, methods for extracting it. If you're working in technology, maybe you need to describe the parts of your computer, or how much RAM, how many gigabytes that you can store, those sorts of things, right? So what's our business case? What information do we need to store? And how do we need to leverage that? And then how do all of those pieces relate back and forth to one another? Strictly speaking, we've said zero about what format it needs to sit in. Really, all we need for an ontology is that it describes what are the things that exist and how do they need to relate to one another. That could be an open, free text PDF for all I care, right? That's what the ontology is. It's just the account of what exists and how those pieces interact. Here's a metaphor that might be helpful if you're still not quite sure that you're locking into what an ontology is supposed to do. So suppose you have a child who's learning how to read. They've got a book. It says pumpkin in it. They're sounding it out. They don't quite yet know what the word is because it takes some time to sound all of those letters. But they know all sorts of things about pumpkins, right? If you ask them, what's a pumpkin? Oh, I love those. They're orange. They show up in the fall. They make delicious pie. I carve them. I make scary faces for jack-o'-lanterns, that sort of thing. And so they're sounding it out, and then they have that aha moment. They see that the word on the page refers to that concept that they know so much about, right? They've connected that word to their conceptual web, their conceptual understanding of the world. That conceptual understanding is the way that I think of ontologies. And in artificial intelligence, ontology in AI provides a web of concepts so that the AI can understand the data it's processing. And whether you think that's real understanding or not, that's a discussion for another video, but it provides a bunch of interconnections that can help your AI process it as if it were understanding. So let's look at a specific case to anchor that. In healthcare, you've got some data. We see this spreadsheet. It's got columns for first and last and date and specialty. And as a human, you're reading that, and I bet you can pull a whole bunch of information out of it. You can infer, well, there's some person named Casey Hart, and on August 17th, 2024, they went to an oncologist named Dr. Barrett in Austin. They weren't referred anywhere, but they need to follow up in 6 months. And you can infer follow-up information from that as well, right? We know things about Dr. Barrett. She's an oncologist. Or he's an oncologist. We know that they went to school. They have an MD. They've probably had to pass state boards or some sort of other like government agency licensing procedures. We're betting that the location Austin is referring to Austin, Texas, perhaps. We know that 6 months from now, we know what date that's going to be. So in February of 2025, we're going to need to do a follow-up appointment. We know that Casey probably has cancer or has some risk markers for cancer, because why else would you go to a doctor's appointment about oncology, right? And all of this from just the few lines of text that we see up there, the few words that we see up there. But think about what your computer can infer from this table. Probably not very much. It's going to know that there are certain data types. Some of these are strings. Maybe one of these is a date. We might format some things as integers. That helps a little bit. But really, we're relying on the fact that this structured information is going to be interpreted by someone or use some other code where the person who wrote that code knew how to interpret the data. In ontology should be a more robust mapping that allows our data mapping to be related to the concepts in the same way that those concepts are related in your brain when you're thinking about all the information you could pull out of this table. So here's an example of how we might graphically represent an ontology. You can see we've got our patient there of Casey Hart, and Casey's connected to a bunch of things. It's connected to the properties of Casey's name. It's connected to the type of thing that it is, a patient. It's connected to this particular visit. And this visit was a medical care event. It was presided over by our Dr. Barrett, who's an oncologist, which is a specific type of medical doctor. But it's not just the lines that we saw in the data, because it also knows general things about patients. Patients and medical doctors are specific types of persons, right? We know that medical doctors preside over healthcare events. We know that oncologists preside over healthcare events and treat cancer, right? This is a simplified view. Of course, the real interconnected graph is going to be much more complicated than this, but hopefully this gives you a feel for how this gets fleshed out. So in summary, ontology in metaphysics is the study of what exists. In AI, it's the web of concepts that lets the AI understand your data. And that means a lot of things. It means what kinds of things are there, like doctors and patients. It means what individuals are there, Casey, Dr. Barrett, a particular doctor's appointment, and what properties they have, like names and dates that they occur on, and how those things interrelate to one another, like that your follow-up visit is going to be caused by your initial visit. That's it. You now know what ontology is, what an ontologist does. How we put them together is going to be a topic for a future video. So I'm going to get into a lot more depth on this channel on how we can use ontologies. How do I think about them as languages, as graphs, as models of reality, how I build them, specifically OWL RDF formats, and then how we can use them, and just as importantly, how not to use them. Ontologies are tools, and they should be used in situations that's appropriate. And then lastly, how do ontologies relate to artificial intelligence? So it's the map that allows AI to understand your data, but how does that actually work? How can we bring that to be? I hope you like and subscribe this video. And if you've got future video topics you want me to cover, drop them in the comments. I'll be reading them. I'll be regularly updating this channel. I'm really looking forward to getting it going. And thanks for joining me for the first one. Have a great day.